Okay, now we're going to do part 2 of order of operations. We're going to evaluate an algebraic expression. So what they're going to do is they're going to give you an expression, an algebraic one. I don't want the eraser. Which means there's going to be variables in it. Alright? So we're going to try to evaluate this expression. Okay. If I'll make it all pretty colors. If x equals 4 and y equals 3 and z, like that Packer green, z equals 2. Okay? So what they're going to ask you to do is replace those variables with their values. And it really just becomes another order of operations problem after we do that. So here we go. We have 2 times x squared, well x is 4, so I'll put that in red. 4, we're going to square that, we're going to subtract y, its value is 3, so we're going to substitute that in. And then we have z, which is 2. Put that in there. We're going to square it. Alright, so we've made our substitutions. Now we're left with just a mathematical expression. And we're going to do the order of operations. So we'll parentheses first. Inside the parentheses we have an exponent. We need to square that 4. Okay, plus 2 squared. Next, parentheses still, there's an operation there. 16 minus 3 is 13, plus 2 squared. Now there's parentheses there, but that's just kind of separate and show that I have multiplication going on there. There's no other operation inside those parentheses. So next thing I need to do is that exponent out there. So we have 2 times 13 plus 4. Multiplication and addition, we do multiplication first. 2 times 13 is 26. And the final operation, 26 plus 4 is 30. Okay. Next, we'll do a real world application. Where are we going to use this stuff? You guys always ask me that. Well, here's the situation. In California, an average of 539.2 fires are started by burning debris, while campfires are responsible for an average of 129.1 each year. Okay, so what they were going to want you to do is write an algebraic expression that represents the number of fires on average in D years of debris burning and C years of campfires. Alright, well, in 1 year there would be 539.2 fires started by debris. In 2 years, I would have to double that, or times it by 2. In 3 years, I would multiply it by 3. So what are we doing? We're taking that 539.2, and we're going to multiply that by the number of years we want to predict there will be caused by debris. So like I said before, in D years. Okay, if it was 2 years, D would be 2. 3 years, D would be 3. I multiply that. Then, separately, if I want to know how many campfires are started, or how many fires are started by campfires, I would take the 129 and multiply that by the number of years I want to predict. Okay. We said that would be C. If I want to find the total, go to the grocery store and get a total, they add it all up, so we're going to add that all up. Now to evaluate how many fires would be in 5 years, well, D represents years and so does C. So I'm just going to replace D and C with the number 5. Put that in parentheses. 1. Oops. Okay, so let's use the order of operations here. Okay, have multiplication, then addition, then multiplication. I kind of have two separate multiplications, so I'll just do them both at the same time. It's not going to hurt anything. So when I multiply these two numbers, I get 2,696. Multiply that, I get 645.5. So if I were to make a prediction of how many fires there'd be in California in 5 years, I have to add these two numbers up, and I get 3,341.5. And I can't have half a campfire, so I would probably round that up. And that's how many fires we would have.